which is an enhanced network mobility solution at the IP layer. So, some of you might have seen the multipath TCP talk before today. So the problem we're trying to solve is quite similar. So, for example, you probably know that you have some SSH sessions, you close your laptop, switch to a different room, open up your laptop. As you type your first letter, you get the infamous write failed, broken pipe. How many of you have seen this message? Yeah, so you know what I'm talking about. It's quite annoying. So this happens because the transport layer connection gets broken. So it would be nice if switching from 3G to Wi-Fi or switching from one room to another to getting a different IP address would not broke our connections. There are some solutions already. So for example, you could use tunnels or VPNs to work around this. Personally, I use an IPv6 to play around with IPv6. I have a free 6XS tunnel. And with this, I actually had the great experience of closing my laptop, opening up in a different place, and SSH session was still ongoing. The problem is that you get higher latency because of the path stretch. All the traffic goes through centralized node. You can also think about the privacy issues. Then there is a mobile IP, which for IPv6, it solves the path stretch problem. So the connections go directly between the communicating nodes. But it doesn't. It's not solved for IPv4, and as much as I hate to say it, IPv4 is still here to stay for a long while, I think. So the research community has been talking since more than 2 decades about the fact that the IP addresses are overloaded with different semantics. They identify nodes. Well, actually interfaces, and also they are used for routing packets in the internet. So there is a proposal to separate this overloading of the IP address and have identifiers and then routing locators. So in this new system, what will happen is that users will keep using DNS names, but these DNS names will resolve into identifiers of the endpoint that are communicating over the network. And these identifiers will not be used for routing packets, only for terminating transport layer connections. So for example, there is no difference between syntactically between an EID and a routing locator. There are both IPv6 addresses, both IP addresses, but they have different meanings. So it's like creating dynamic tunnels. Instead of going through a centralized node for tunneling my connections between the 2 communicating nodes, I would create a tunnel between my end host to the other end host. Both end hosts need to support for this new system, but there is no path stretch. If one of them doesn't support it, there are also solutions for the transition with proxying node, similar to multipath TCP. So LISP is the locator identifier separation protocol, which is being standardized within the IETF. It's almost an RFC now. And then this is meant for routers. And then there is a lightweight version of LISP, which is called LISP Mobile Node, which is a global IP mobility solutions. It supports multi-homing, so you can have more than one interface, even more than one active at the same time. Supports ingress traffic engineering for these separate interfaces. You can define priorities between them. And changing your network attachment point doesn't affect your transport layer connections because your This is not as close to an RFC as the main specification. It's still an IETF draft. It's work in progress, so you could even influence its outcome. So what happens when you're communicating is that, as in tunneling, data packets get encapsulated. Lisp uses UDP encapsulation. Above UDP, you have a Lisp data header, which can contain some protocol-specific data. And after this, the Lisp encapsulating header, you get the original packet, which was sent originally by the host. So the current version of our implementation supports both IPv6 and IPv4 packets, but only over IPv4 connections, supporting interfaces. There is a work to support IPv6, and hopefully it will be supported soon. So you might ask yourself if this works behind network address translators. The current version of the code doesn't work because of the need to set up incoming connections, or to need to set up state. But there is an traversal specification under work currently, and our project is already working to implement this specification, so it will be soon supported. For now, if you want to play with the implementation, you need a globally routable routing locator. So a bit about the project. Initially, this was an internal tool at Cisco Systems for the IETF protocol specification development. So they were using it to develop the LISPMN specification, did some tests. Then the Technical University of Catalonia from Barcelona, Spain, became the open sourcing partner for this code. We've added some features and improved usability, because since it was very, very developer oriented, it was very hard to use. And we are right now starting to build out a community around the code. We placed it on GitHub. We have a web page with contact information, documentation, and so on. And we can provide identifiers to early users and developers who are interested in playing with the code. The architecture is divided in both kernel and user space. So there is a new virtual interface which gets the identifier. Then there is a kernel module which is doing the encapsulation, decapsulation of data packets. And the user space daemon called LISPD, which implements control frame functions, interface management, registering the EID to locator mappings to the mapping system, doing the lookups, and signaling handovers, and so on. And that communication between the components is over netlink sockets. Some of the platforms supported, you can see here. So we support generic Linux. We have an implementation for Android Gingerbread, OpenWRT, and we also tested it on the Nokia N900 with MeeGo Community Edition. Development was mainly done on Ubuntu long-term support 10.04. We are going to soon switch to this year's long-term support version. In order to work, Network Manager has to be disabled because it interferes with interface management. On MeeGo, we had to compile a custom kernel to enable advanced routing functions, also to disable Connection Manager, but the actual code didn't need any modifications to make it work. The Android port is developed by Chris White. It has a different control plane, which unfortunately is not yet open source, and I'm hoping and doing the best I can to get it open sourced. And there's also an OpenWRT port, which was developed by Vasileios Lakafosis, tested on the Linksys WRT 160N router, and the changes necessary to include it in the distribution are being reviewed by upstream distribution. There are some other open source code bases implementing Lisp. There is one for FreeBSD called OpenLisp. There was also a Google Summer of Code project in 2010 by Alex Lorca. But this one was developed in parallel, so we didn't know about it at the time, and it had very little activity after the Google Summer of Code finished. So in order to actually participate to use Lisp, you have seen that there is the mapping from DNS to the identifier, and then you need the mapping from the identifier to the locator. There is a supporting infrastructure. For each region which hands out IP addresses, there are a few mapping servers to do this. So if you're trying out, you're going to be registering your IP, the identifier allocation to one of these servers. I also developed a small tool that will discover identifiers on the internet. It's crawling the mapping system and tries to geolocate your locator and put it on a map and have a nice tooltip with some information about it. I have also implemented a dissector plugin for Wireshark, so to make it easier to do development work for this project. And we're also now looking for projects that could leverage the functionality in this project. So if you are a developer for a project or a distribution that is interested in providing this kind of mobility, working on Lisp mobility with us, maybe even participate in the shaping of the protocol, let us know. Also, if your project has some specific needs for interfacing with this kind of functionality, let us know so that we can adapt the code for it. So, for example, if it works with dboss, then we will have to develop a dboss interface for communication with your project. Here are the links. So the first one is the main project website. Then you have the GitHub link. And the last one is the protocol specification for Lisp mobile node, which is developed within the IETF. This is it from my side. So if you have any questions. Okay. Thank you.